This is problem 4-33. The way I would approach this problem here, you have two different materials. Kind of blow this up. Oops, sorry. Going to blow this up at one end. We're going to look what's taking place here. So you're going to have two pieces of material here sitting up like this. Kind of like this. And what's going to happen is you have the 80 that's being applied down. Okay, what's going to happen is these two materials are both going to deflect like this. And this will be your deflection overall. So what you want to do here is each one of these is going to push back. So you could think about it in this term here. You have the outer, which actually is hollow, kind of like this. It's pushing back. And oops, I'm getting my straighter than this. And the outer material is what? Steel. So you could just make this F of steel. Now the concrete is in the middle, and it's pushing back too, like this. So basically you can say this. You can say the summation of forces in the y direction is going to equal to 0. You'll have minus 80 kilonewtons coming down, so you have 80 plus the force of the steel plus the force of the concrete must equal to 0. So all you really do is they each have to deflect by exactly the same amount. The concrete can't deflect more than the steel. Steel cannot deflect more than the concrete. So everything here is just based upon PL over AE. So all you're going to do is set these equal to one another and then solve. So set this problem up like this. The force in the steel over its length, and the length is going to be 500 in this case here. You can put, if just to save time, you can put in the 500, or you can just put an L. I'll put in the 500. We're going to cancel them out anyway if you look. Okay, now it's going to be hollow, so we got to do pi. We're going to do pi d squared divided by 4. We take the outer, and we take that value of E, which will be steel 200 times 10 to the 9th. We'll just set that equal to the force in the concrete times its length, which is 0.50, over pi divided by 4 times the diameter, which is 0.07, squared times E, which is 24, times 10 to the 9th. Okay, what you're going to do here is solve, just solve for this equation here, because these are equal to one another, because the deflection has got to be the same. Again, what I would do at this point would I'd just cancel out the lengths just to save time. You don't have to, but it's going to make things easier. And you're going to find that the force of the steel is going to equal to 2.551 the force of the concrete. Then all you have to do is come back to this equation right here, substitute it back in to there, and what you'll find out is the force in the steel is going to equal to 57.47. The force in the concrete is going to equal to 22.53. And this one wanted to know average normal stress, so just P over A. That's all you got to do on that one. So the stress in the steel, this is going to be in kilonewtons too. and you're going to divide it by the area, which here would be pi divided by 4, 0.08 squared minus 0.07 squared, and that's going to give you 48.8 megapascal. This would be a great test problem. It's not a hard problem at all, but it kind of shows what you do know. And then the concrete, you come back to here, 22.53 times 10 to the third, and then pi over 4 times 0.07 squared, and that'll give you 5.85 megapascals. Oops. Okay. So this is the approach you're always going to use when you have something like this, and it could have 2 or even possibly 3 different materials. You'll just have to have enough information to find the 3 unknowns if it does have 3 material. But again, the thing to note is the deflection for each of these has got to be the same. So draw it like this. Sum the forces in the y direction. You'll get one equation, and then set the 2 deflections equal to each other. Just make sure that you note that the force in each one of these materials will be different. So you're going to have 2 unknowns here. Find one in terms of the other, put it back into this equation, and then the problem just falls apart.